of the IT 380 class. This video is covering now the next part after going through the class introduction for the first week, going through the basics of learning science and HCI. I gave you the related works on my dissertation to go read through. And then I gave you a 20-minute video. This was a presentation of a recent study where we did binary counting in VR. And I'm going to be talking about this as an example. This VR game we made. We also made an AR. We made like a level 2. So all these different parts I'll use as examples throughout the class. And then, this is my dissertation proposal. So some of you might be interested. It's like an hour and a half long, but it's me presenting what I think my final research will be to graduate from the PhD. So I have to lay the groundwork a little bit more, the more related work. I have to introduce the people to the main topics that I'm going to be talking about. And I present on 3 studies that are hopefully related enough to warrant a strong conclusion that some type of results from all 3 studies combine into a original piece of work, research work, that's worthy of a degree. So if you're interested, you can watch that. It's almost like a rough draft. Like I made mistakes. The committee critiqued me and said you have to fix this and this and this if you wish to graduate. So, if you're interested in going a little bit more down the research route, it might be interesting for you to watch. Now, this video, I'm going to be talking more about UX research in general, this idea of a double diamond. I'm going to come back to what these projects are about. And it's meant to be a shorter lecture because I'm going to make another lecture after it to cover these lecture slides and then this class activity. And then we're done for the week. Now, since this week was heavy with a lot of introductory topics and ideas of education and learning science and research and software design, I'm not going to have an aspect of programming for this week. But starting up next week, we'll be mirroring our work of design into building the prototype in Unity. So we are following what's called kind of a double diamond design in UX. Although that diamond just opens and closes forever, the double diamond is referring to the fact that you have to kind of open up a phase of a project focusing on researching a problem, and you must open it as widest as it can be, all your possible problems that you could possibly research, which ones are the most interesting as you're closing down, and then you kind of pick a problem and you thoroughly define it. So that's the first diamond of the double diamond. And it's interesting when people first learn about how to design something. And design crosses all boundaries of art and engineering and science, and all human domains have an aspect of first having to design something. The process is actually interestingly very similar. It's been abstracted enough, over the course of human civilization that found that you have to understand what your problem is before you can even attempt to find a solution. So no matter what you do, what career you pick, what discipline you're in NGIT, first researching what it is that you're trying to solve will make your design infinitely stronger. And then going through an actual design phase makes your implementation, your build phase, your develop phase just infinitely stronger. So most people in computer science will just start diving in and just start programming something. And your ideas in your head, your vision in your head feels so clear that you don't need to spend any time up front, and you just feel like you know the solution already, and you jump in, and it's just a recipe for disaster. But that is a learning experience of itself. And usually, okay, you'll start building something without even doing any of these initial phases, and then be like fail several times and realize, oh, maybe I need a little bit of design. So let me start figuring out. Let me look at other people's stuff. Let me kind of usually grab and borrow and steal other people's implementations, and you'll think that that is design. And that's kind of the first step of it. And then as you design more and more before you build, and you fail a lot, but you're building something better, usually you realize that there's even a prerequisite step before that. And that is you first have to really understand the problem before you even can understand what are the essential the solutions that fit that problem really well. So here we are in week 1. Next week, and I know this feels soon, but it's a light deliverable, and I'm gonna in the next lecture video I'll cover it. Right at the end of next week, on Sunday, September 13th at 11:59 p.m., your midpoint's going to be due. And it's about a page and a half. It's about giving a problem statement. What little small part of education, of teaching something, a little learning nugget, learning topic do you wish to approach with your educational technology? And then you review the competitor space and see what people do right and what people do wrong. Now, just so that you're aware, we're kind of getting to the end of the first week, and yes, sorry that I'm late on the videos, but I'm building up steam, and we actually thought out a lot of the class, and so we'll be using the Espresso project as kind of a finished example. And it's in a later stage of cycling, and we're going to be using this new Canaan project. We'll be building it with you so that you have a guide to follow throughout the class. But this midpoint deliverable will be due at the end of next week, and this is supposed to be here where we're opening up the diamond. So we're trying to train you in each step of the phase how you open up your widest possible idea space and how to close down on a good idea and move on to the next phase. So that's why we have a grading element and a feedback element basically every 2 weeks. When you open the diamond and you close the diamond. So next week we'll be here. We'll be at the widest part of the research diamonds, and this is the widest area of possible problems that you could solve. But even that is kind of scoped. Like you've already kind of picked a subject, maybe a subject, a section of a class that you really liked, or a small lesson already, and you examined that wide breadth of competitor space of how that problem is currently being solved and what was right, what was wrong to help guide you. So you could even say there was a diamond before this. Like, how do you pick which subject? And how did you even pick that we're in education? So, and that's why these diamond structures, although they look linear in time and you keep picking new problems and solving them. And actually, in software design, an iterative approach, you do this over and over again while you're actually building a piece of software. You move on to another feature, and you research it, you design it, you build it. But we just had to start somewhere, and we're teaching a small little section of it. And so we're saying for your research phase, you kind of have to pick a subject, and then you go and research all the competitors. So it's kind of like a compressed research diamond. And then 2 weeks later, at the end here, we're going to close the diamond. We're going to have you pick your problem area. You have after you've picked your problem statement and you've picked your and examined your competitor space, you're going to identify your stakeholders, your users. You're going to build a persona. We'll get into what all that means. And then you're going to have to build a scenario or two, examining the problems that these personas, these abstracted people who are using your app are in. And then you're going to do a light level design for the intro of your app. And so these remaining weeks in research will also have a programming aspect. We're going to build the lightest part of the prototype, which will be just the intro. It's kind of like a splash screen, like a slideshow of your research, like explaining to the user what's the point of this app, And then we're going to close out that diamond by presenting half the design doc and presenting this intro. That will be a WebGL build. So some of you asked for the midpoint. Yes, there's no programming. It's just going to be like a 1 page, page and a half, um, a text and maybe some images that you put up on Canvas for the midpoint. And then for the endpoint, that'll grow much larger, and you will have a WebGL build. So then we'll move on to the design diamond and the prototype diamond, and it's a similar fashion. You open up, you explore a massive space, and then you pick something. For design, you're gonna pick a solution to your problem, and then for prototype, we're gonna explore and pick an implementation of your solution. So hopefully the class makes a lot more sense. And since feedback is a really big part, there is no late assignments. Whatever you have, please submit. And I'll send up reminders. I'll have to train you at time management and project management. It's really important, and software development. And someone working in the team, as you're given deliverables and expectations of adding something, contributing to some final product, that you're expected to do it on time. Again, if you have a real emergency, something really happens, go to students and we'll work with you. But the mechanism is you deliver Sunday nights up to 11:59 p.m. and then that next day, at the end of the next day, everybody should have done the feedback part of the deliverable, and then you all get graded. So feedback will cover what that means, but it basically means going and reviewing 3 other students' stuff and giving them constructive criticism. Actually put some critical thought into whatever their deliverable is, and you're always going to find issues. Nothing is ever perfect. We're always trying to achieve that, and we're always trying to refine what we're making and building, and so you're going to pick out some good things, pick out some bad things, pick out some flaws, and then suggest how to improve it. Give some constructive criticism for every negative you point out, and help them improve their project. And then us as the instructors do the same thing. So very quickly, you might let me just cover subjects. So for this September 13th delivery at the end of next week, we're going to ask you, you have to pick a educational subject and then a sub-subject and maybe like a small assignment within that. So we're going to, there's many different ways that human knowledge can be broken up, but the easiest I'll just follow is kind of branches of science. So when you think of this, picking like your largest field that you wish to find a small little solution to a technology, you can think of formal sciences, basically logic and math. You have natural sciences, physics, chemistry, biology, cosmology, geology, ecology, which is life, which is what we're going to be working on with the Canaan project. And then the social sciences, so sociology, psychology, economics. What's it? It's some like public administration, MBAs, business. And I think that pretty much covers everything. You could put languages and linguistics and history underneath here. And if there's and so applied sciences like the engineerings, you could think of like applied sciences, sure. So mechanical, chemical engineering, electrical engineering, industrial engineering, and then you could, of course, you can always keep splicing and splicing. So it's like industrial design and interior design and digital design, and where do they belong in architecture? But at least it gives you sub area to start exploring. And if you wish to pick something that's not even in here, like woodworking or homemaking or cooking or sewing or knitting or sports, that's fine too. I'm just trying to give you some area to start thinking about. Think back into middle school and high school and your college level, and think about like a teacher that really struck you, or a topic or a class that you really kind of inspired. You really want to be having some inspiration and passion project in this class. So find a topic that's really interesting to you, and you can hone down deeper and deeper and find a small enough, learning lesson to acclimate over to a simulation. And also this McGraw-Hill website, you can see the links here under pre-K to 12, pre-kindergarten to 12th grade. We have some subsections like health and fitness and visual performing arts, language arts, math, science, social, world languages. So you can hopefully find something that piques your interest. All right. So let's continue on with our conversation about UX research. This is a interesting study we did, and I think this kind of encapsulates the process of research that you'll be doing in a smaller way for the first diamond. And if you're interested, it's under social VR here, usability study. So usability means how usable is something, how easy is it, intuitive, friendly, what type of experience does it give to the user when they use this thing. So this is all borrowed from industrial design. It used to be all these industrial machinery and household appliances, and then the software field adopted that for UX. So basically here we're stating our overview and our background, and we get into the case study. Case study just means we're examining one scenario that has happened in the past, and we think it's interesting enough in light of UX research to present it as a case study. In this case, we did a research study on how to train incoming freshman STEM engineering students for collaboration, socialization training. So what we call learning communities, your social, your informal social groups that you go to, you have people to go to, and you get stuck in your math and science classes to help you get better grades and help you understand your topics and help you have a better career. So a lot of students don't have these learning communities as they go into college. They have to build them, but they might not have the correct skill sets. And we don't have this formal training here at NJIT. So we did 3 groups in this study. One was our control that had no actual learning community training. One group did it physically, in person, around a table. And the third final group did it in virtual reality, remote from each other, but connected through a virtual space. So this study happened, it went through, and we collected all this additional data, what was happening in VR, because it was a lot of people first time using virtual reality, and we videotaped them, all these groups, and we saw that they all had these kind of usability issues. And so we wish to examine it more. We wish to go through another research diamond on a whole new problem that we saw was of interest that's stemming out of another study. So another spiral of diamonds to study and build something with. So video ethnography, ethnography means studying someone. Ethnography is coming from the social sciences, anthropology, how these academics would go out to these remote tribes in some, jungle island, or, in the jungles of South America, or studying some tribes and understanding what their culture is about. But this is the idea of that you're observing other people in their kind of natural habitat without disturbing them, without them being aware that you're there. You wish to see what they're doing. So this idea of ethnography applies well to UX because you're kind of watching the users. You collect data on them. They're not aware. All these apps you're using in your phone, they're collecting all this data on you. They want to improve the experience. They're doing ethnography on you. In this case, it was video. We were watching the video. After watching them and writing down all these notes and observations, we kind of distilled all the observations down to these little themes as briefly as we could. And then we had these pile of sticky notes with all these themes, and then we organized them into what are called affinity diagrams. So this is the first step of trying to organize all these notes. and they fell into these major categories of these broad categories of VR factors, or platform usability issues, familiarity issues. We had content issues dealing with the items, the actual objects they were interacting with in VR, and the instructions that were given to them to actually perform tasks in VR. And then we had collaboration issues that revolved around interacting with these items, that the students had issues interacting with each other, with issues about these items, these 3D models that were in VR, and about the process of how to go about solving the problems that were presented to them. So once we had this level of organization, we did what are called experience maps, which is we broke down the user experience that they went through this task, and looked at their thoughts, actions, and feelings to get an understanding of their perspective. So in this case, this is like represents a time-based flow of the experience. So first, they're given instructions. Then they're asked to individually rank these objects. That's what the task asks them to do. How valuable are each of these items presented to you? And then the group must come together and rank the objects as a group. And then they must get scored and ranked based on their decisions. So at each major phase of the task, we have what are the users doing, what are their behaviors or actions, and what are they saying, what are their thoughts and feelings. And then this gives us another breakdown of their experience, another way to start looking at the problem space. Remember, we're opening up that diamond. We're trying to get as much information about this problem space to figure out what is the problem that we can look at. Once we did that, we made user personas, which we're going to get into, I think, in like 2 weeks. So basically, you have to observe enough people in an ethnographic way to kind of distill their characteristics and find these prime abstractions of people, these prime archetypes that or avatars that would represent your ideal user for your app. I'm just going to skip this for now, but ideally you get a breakdown of a few of your prime users abstracted away that you could think about their issues when you're trying to build your software. And then we have the problem scenario. There's many types of scenarios, and scenarios are just meant to document a phase of life, a part of what the user is doing, just to help you understand them more. And it's like the last step before designing a solution for them. And scenarios can be problem-based, activity-based. There's a few others. In this case, we did a problem scenario. We're presenting a problem that the user is having. The user is having a problem identifying one of the objects given to them. So they can't interact with their group. They can't make decisions on this object because they have no idea what this object is. In this case, a sextant. A sextant is a old school navigation device, and for ships. And most people are just used to like digital and electronic instruments, and they have no idea what these old school analog instruments are doing, and no one really gets involved with sailing anymore. So, and even if we say the word sextant, it is a strange word, and we had a lot of English as a second language speakers, and so they weren't even familiar with the word, even when we told them what it was. And so there was kind of a listing, an onion of layers of issues with these objects that we could pick a real problem, a slice of the problem that we wish to solve. And so we had our problem scenario and our problem statement. And with that problem statement, we closed the research diamond and started our design diamond. And I'm not going to go into this here. We'll go into this later. But we have a well-defined problem that leads into a defining a solution. And we iterated and iterated solutions until it came up to what we like. But that's for later. So, if you wish to, the Espresso project, you could go to the dev blog and go all the way to the bottom. And this was when we first started researching how we wished to create this world that we ended up making a design doc for, and we ended up building a prototype for binary counting in virtual reality. Now, this is the design doc for the VR experience, and you can start to skim through if you wish to. This is well later on in the class, but what I want to show you is that you could go to the dev blog down here, and you can actually in reverse or just go to the bottom, and you can actually move through in chronological order and see like what we were thinking. We tried to document as well we could. Like we had our first team meeting, we had our opening discussion. What's our problem? How do we find the problem? We settled on binary math. What does it mean? What does it mean to do this in 3D, to move around when such an abstract learning lessons? Usually you're sitting at a desk listening to a teacher or reading a book. You can kind of see what our thought process was like as we were going through research. And yeah, this is the. So I asked you to go through. Hopefully, this all made sense. You can email me questions, and I can answer this in another video. But I'm going to quickly go through that. First, you introduce what it is that you're doing, what the problem is that you're trying to solve, and hopefully you listen to my 30-minute talk on or 20-minute talk on this. And that you're supposed to boil down what are these distilled research questions? What's the ultimate thing you're trying to look at? And then you're supposed to ground yourself in related work. That no, this is fertile ground. Other people have been exploring around. It's just this little niche hasn't been explored yet. And then you state your method of your research, like your how are you going to go about this research experiment? What is your aim? Who are these participants in your study? And how are you going to group them up? Then you, in UX research, you have to talk about the system and the stimuli. So the system is the computer system. What did you build? What was the hardware? What was the software? Why did you build it like this? What was the software design? And then you might say the stimulus. What is the stimulus of the computer system to the user? So in this case, what are they seeing through the headset? What are they hearing through the microphone? What are they presented with and interacting with through their hand controllers? And then here's more talk on the system of the user actually moving through these stations in a 3D world. Is a top-down view. There's an animation that plays. This kind of presents what we went through like 2 cycles. One was like the low fidelity. It's like the low fidelity prototype. Just get it working with very basic graphics. Once it's proven to work, we then spent some time refining it for more of a finished version. And so the implementation of the study, how do we assess the participants before they actually get exposed to the session, to the treatment, so that once after the treatment we do a post-assessment. You have to do a pre-assessment and a post-assessment because you have to see a change. So then you have to figure out what the assessments are. Do you do surveys? Do you interview them? What exactly are you trying to find? Are you trying to look at different interactions to see what's funner, what's easier, what's more engaging, what makes more sense? Are you trying to see if they learn something in this case? So you have to test their knowledge before and after. And then if you're interested to see how long they remember, called retention, you might keep testing them at different lengths later on. And then you have to talk about, so here are the assessments that we did, these multiple choice questions of binary math. And then we did an interview. So you have to talk about what's your process, your protocol for how you're going to interview people to make sure it was a clean process, that you're not introducing bias or dirty numbers. Then you can present your results. So after all these knowledge surveys I took pre and post, we could graph them and we can do some statistical analysis to see what happened. In this case, both groups showed that they learned there was a change pre to post statistically. Or they both learned at the same amount. There's no difference between the two groups of live and VR. So meaning VR is just as good as live. All right, and then I did a lot of interviewing because I was interested in what the VR participants to see if they were interested and they liked the VR experience. We had a lot of positive experience emotions compared to negative. So the thing with interview data, what they call qualitative data, it can be very like loose and fuzzy, not as good as like number, like quantitative, like biometric data or doing surveys. But you can get more data. But in this case, we did see that they talked a lot more about their positive emotions, which means good. We can call it a successful user experience. And then you wrap up with a conclusion. We found something. We went out to look for something. We did look for something, and we found something. And I think that is all I'm covering in this lecture video. And then I just have one more quick one to cover your in-class activity, yeah, your card game. This will be much quicker.